It's my pleasure now to introduce Dr. Susie Wood. Susie is based at Cawthron Institute in Nelson and does great work in harmful algal blooms, I recall, and lake water qualities. Over to you, Susie.
Thank you. So hi, I'm Susie, and so those are just a few of my favourite places in the world. And so I feel really privileged to be a freshwater scientist working in New Zealand and helping to understand and protect and manage these really, really valuable resources. I want to acknowledge my co-authors on this presentation. So they all form part of the MB-funded research project understanding the health and enhancing the resilience of New Zealand's lakes. So I want to address three key questions in this presentation. Just how much do we know about our lakes in New Zealand and how healthy are they? Can restoration be successful? And how can science help to contribute to the understanding of our lakes and enhance resilience and restoration? So we have about 3,800 lakes in New Zealand. There's only monitoring or robust monitoring programs in place for about 150 of those. There's another subset of lakes that we know a small amount about in terms of native biodiversity and perhaps invasive species. But really the large majority of our lakes in New Zealand we know very, very little about. Of those lakes that we do know something about, the data sets tend to be very biased. So we know quite a lot about, in particular, our lowland lakes, but our high alpine lakes, for example, we know almost nothing about. And this makes it really challenging when we're trying to do national scale assessments of lake health. And I think that's going to be a real challenge going forward when we're trying to measure whether lake health is improving in New Zealand, because we don't have a very robust baseline. So of those lakes that we do know something about, what is lake health like? So this is data from 112 monitored lakes. There are now slightly more monitored lakes than that. And in New Zealand, we tend to use something called the Trophic Lake Index as a measure of water quality. So this combines nutrients, algal biomass, and water clarity. So we have our mycotrophic and oleotrophic lakes. So these are our very good or our good lakes. We have our mesotrophic lakes. These lakes slightly nutrient enriched, perhaps some algal biomass. And then we have our eutrophic or super eutrophic lakes. And so these are our ones which are highly nutrient enriched. And typically during summer months, these ones experience severe cyanobacterial blooms. This is a photograph from Lake Tuatera up in Napier. So over 50%, or around about 50% of our monitored lakes are in this eutrophic or super eutrophic state. And this is typically our lowland lakes and our highly modified catchments. So when lakes get to this state, what can we do to restore them? And how successful is that? What I want to do is just use two examples from around New Zealand to show you some of the challenges, some of the successes, and some of the costs involved in restoration. So there's been around about 30 or 40 lakes that restoration has been undertaken on in New Zealand, and a range of different strategies have been used. These first ones, such as catchment management and inflow diversion, the aim of them is really to reduce nutrients reaching our lakes. Then we've got a bunch of different techniques which we can use within the lake to try and remove or reduce nutrients. Things like phosphorus inactivation compounds, weed harvesting. Things like the sediment capping and the mixing and aeration address these legacy effects that John so nicely described. So these are things like the sediment in the bottom of our lakes, which are really nutrient enriched. And under certain geochemical conditions, those nutrients are released back into the lake. And if we want to restore a lake, we absolutely have to address those legacy effects. Biomanipulation involves altering food webs to try and perhaps restore natural balances, or using organisms to remove algae or invasive weeds. And so, sorry, now I'm actually going to show you the two examples. I was a little bit ahead of myself before. So the next few slides cover two examples of lake restoration in New Zealand. So the first one is Lake Okaro. It's a small lake about 20 kilometres south of Rotorua. It has a long history of water quality decline. In the 1950s, it was a clear water lake and was fully oxygenated throughout the water column. Since the 1970s and until current day, it experiences severe cyanobacterial blooms. In the early 2000s, the Bay of Plenty Regional Council started up an action plan to try and improve water quality in this lake. So they've used multiple restoration actions, including the building of a wetland, which you can see here, to try and reduce nutrient inflows into the lake. They've used dosing the lake with phosphorus inactivation compounds. This one is a compound called LMP. It binds the phosphorus in the water column and reduces available phosphorus. They've also used sediment capping and a whole bunch of looking at the best farming practices in the catchment. So how successful has this been? So if we look at the TLI, when they started this program back in 2002, it was at 5.6, so a super eutrophic lake. They set a target restoration goal of 5, and this was achieved in around about 2012. And there's been some small progressions or improvements in water quality since then. But it's still a eutrophic lake, so they've made gains, but we've still got a long way to get it back to what that lake was once like, or like in the early 1900s. And this summer, for example, there's been severe cyanobacterial blooms between December to April, such that all recreational activity has been prohibited. And the cost of this, just in a small lake like this, has around about been $5 million if you just look at wetland and the dosing of those chemical compounds. So a small lake, what happens when we scale it up to a much larger lake? So another example is Lake Rotorua, much larger now, 80 square kilometres. Also a long history of water quality decline. The wastewater from Rotorua City was pumped into the lake in the 1970s and 80s, and there's been huge changes in the catchment land use, a whole lot more agriculture happening. So again, they've done a lot of great modelling work has been done, looking at the groundwater and nutrient inflows and improving, or is still ongoing, improving farming practices in the catchment. But one of the interesting things they've done is to treat two of the key inflows into the lake with one of these phosphorus binding compounds. And this has resulted in significant water quality improvements in the lake. So in 2004, when the program was started, had a TLI of 5. They set a target TLI of 4.2, which was met in 2011, and there has been not really any significant improvement in water quality, but there are certainly a lot less cyanobacterial blooms in this lake than there once were. But this is an expensive operation, and it comes at somewhere around $10 million a year to keep on dosing those inflows. And I think the important message here is that this is going to need ongoing management if we keep going down that strategy. It's not something that we can stop treating those inflows and the lake will suddenly be restored. So to conclude about lake restoration, hopefully those few examples have just shown you how challenging it can be. And those examples are really just considered water quality, but we know that lake health is much more than that. It's about native biodiversity and cultural and social values as well. It's expensive, and in most cases in New Zealand, there's an ongoing need for intervention to maintain that improved water quality. But really importantly, we must not give up on a single lake, and we should never consider a lake in New Zealand dead. But we just need to accept that these are going to be big challenges and that these are going to be multi-generational projects. And I think really importantly, and something we could put more effort into, is the need to identify now and protect our really vulnerable lakes. So early intervention is going to be much more successful and easier than restoration. So I want to just finally finish with a bit of a positive spin on this talk and show you some of the cool science which is coming out of the Lakes Resilience Program, which is helping to address some of these challenges that I've highlighted. So there's no way we're ever going to be able to monitor 3,800 lakes in New Zealand. That's just not going to be possible. But this is some really neat work that's been led by Maritz Lehmann out of Waikato University. And he's using satellite imagery, remote sensing, and a whole bunch of neat algorithms that they're developing to look at water quality or proxies for water quality right the way across New Zealand. So getting some really neat data, and also can go back historically and look at some of these satellite images and just look at how water quality has changed over the last 15 years in New Zealand. And perhaps will allow us to do some much more robust assessments of water quality, at least at a national scale. So an area that I'm really excited about at the moment is using paleolimnology to help us inform our restoration and set better restoration targets and understand what lakes were once like. So sediment in a lake is laid down year by year and can provide us information on what's happened in that lake on an annual basis, and also what's happened in the catchment. And there's been some really exciting advancements in this field, and perhaps one of the most interesting one is the use of environmental DNA. So there was a whole session on this yesterday, which was really exciting. So the same techniques that were described yesterday, but we're applying them to these sediment cores. Just as one example, this is Lake Ponui. It's a small lake in the Wairarapa. It's really unique in that 95% of its catchment is still in pristine forest. So it provides a unique opportunity to carry out some paleolimnology work. But like many of our lakes and rivers in New Zealand, in the late 1880s, the acclimatisation societies introduced pest fish, or introduced perch and trout. And so there's been a significant decline in water quality. So this is some environmental DNA work, and what we're doing here is looking at the entire microbial community. Back here it's taking the core back to 1,500 years ago. Each of these different coloured bars there is a different bacterial phyla. And in yellow here I've highlighted when Europeans arrived and fish were introduced. And hopefully what you can see from there is, just looking at the microbial communities, is this huge disturbance event. And this lake starts on a completely new trajectory, which is towards much more nutrient rich. So these bacteria here, for example, are involved with organic breakdown, and we start to see the rise in cyanobacteria. So this is just microbial communities, but we can also use this eDNA to understand more about native biodiversity and some of those resilience mechanisms that were once in place in these lakes. So I'm really excited about how we might incorporate this into better setting restoration targets and understanding some of those mechanisms. And the final example is that there's this really amazing network of monitoring buoys in about 20 of New Zealand's lakes. And these collect data at a frequency and a resolution that was not previously possible. So they're collecting data on a range of different things like temperature, oxygen, pH, chlorophyll A, and allowing us to understand the dynamics of these lakes. And the other really valuable thing about these is we're able to use this data to validate lake models. And so another stream of work that we've got going within the program is linking catchment models with in-lake models with food web models. And these lake models in particular are a really valuable tool for restoration. So they allow you to run scenarios. So for example, if I was to reduce nutrient loads into my lake by 30%, would I see an improvement in water quality? If I was to remove an invasive fish species, what would be the outcome of that? And some really, so I think some really neat tools that have been developed there. And just wanted to leave you with this little proverb: me hoki, whakamuri, kia haere, wakamoa. Thank you.
We do have time for one quick question. Would somebody like to ask Susie a question over here?
How representative do you think the current lakes are of the whole picture? Are these the worst 112 lakes, or is the 50% of the lakes being eutrophic or super-eutrophic? Representative of the whole lot?
Yeah, so the data sets that the monitored lakes are biased, so they are in our lowland environment, so it is a bit biased. From the 3,800 lakes, looking at John, 20% would be in a eutrophic state, yeah. So it's all of our lowland, so we have about, 2,000 of our lakes would be in that lowland, yeah, something like that, yeah.
Okay. Well, thanks very much, Susie.